The problem they discovered with range, back here when we did range a minute ago, range was really easy. But okay, let me give you an example. Suppose on your test scores, if I tell you my test scores range from a 68 to 103, what's the range? 35. That would be a range of 35 points. Okay, so I had 30.5 points of variation in my test scores. Okay, suppose I have somebody who completely blew it off and got a 42. Now what's my range? 61. So now my range is 61. Does that really tell me how my students did? Because all that tells me is the range of scores was 61. Does that mean, wow, I had a whole bunch of people who didn't do so hot? No. The problem with range is one wild score, and your range is huge. You really can't trust range very well, because if there's just one high score or one extra low score, it makes the range look gigantic when maybe it really isn't. So they went, okay, we got to find a better way. So since we don't want to be thrown off by that really high or really low value, they said, okay, let's make what's called an interquartile range. Okay, interquartile. What are quartiles? Quarters or fours. So they said we're going to divide our data up into 4 equal parts. And if you divide your data up, imagine this is my data. If I divide it up into 4 equal parts, the middle would be the what? The median, thank you. Okay, and so then they said, well, hey, let's split that in half. Jake, cool it. They said, split that in half. And now I divided it into 4 equal parts. They call the quarter on the low side the lower quartile. And the upper quartile, does that ring a bell? Should. Okay, on your calculator, the lower quartile is Q1 and the upper quartile is Q3 when you're looking at that data on your calculator. So you'd have Q1 and Q3 there. But all we do to find the interquartile range is they want to find out what's the range of the data between the two quartiles. So to calculate interquartile range, you take the upper quartile and you subtract the lower quartile. Okay, the trick is getting it divided into quartiles in the first place. That's where the problem comes in. Subtracting upper minus lower is no big deal. Okay, so we're going to take Nancy bowls in a league. These are Nancy's bowling scores. She's not bad. I'd like to look. I'd like to be that consistently high. That would be good. Okay, so you know, her low was a 125, her high was a 219. That's not terrible. Okay, I am telling you here, there are 33 scores in this set of data. There are 33 numbers in that list. Okay, so we have to, before we can ever figure out the interquartile range and make a box and whisker plot, you have to find the median and the quartiles. Okay, so if there's 33 scores, how do you figure out where the median's at? What number am I counting to? 33 divided by 2, which is 16.5. Now, it's odd. 33 is an odd number. Is it going to land right on one number or between two? If it's odd, then you pair them up. There's going to be one left in the middle. So I would round that up. It's the 17th number I need to count to. It does not matter whether you count from the top or the bottom. Just make sure you're counting them and going in numerical order. So in this case, 17th number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yep. 17th number is 162. So the median is 162. Now, since it landed on that number, when we go to find the quartiles, we don't use that number. How many numbers are above and below 162? 16. There are 16 numbers. So where is the middle of 16 numbers? Okay, so yeah, 16 divided by 2, that's even, so it's going to be the 8th. It's be between the 8th and the 9th number. So you're going to have to find the 8th and 9th number on the top half and on the bottom half. So 1, 2, 3, 4, 5, 6, 7, 8, and 9 is between 144 and 148. What do I do if it's between 144 and 148? Okay, so 144 plus 148. You can see this. Where's the middle of those? 146. Now, is that the upper or the lower quartile? It's on the lower numbers, so it's the lower quartile. Okay, now, where should I count from to find the upper quartile? I have to count to the 8th and 9th number again, but where do I count? You can either count from the 219 at the bottom, or you can count from the median. You'll land at the same place. Okay, if you count from the bottom, be sure as you're counting, you go 219, then come out here to 192. Sometimes I have people who start counting them and they're not counting in numerical order. That kind of messes it up. I usually count from the median here, just go 1, 2, 3, 4, 5, 6, 7, 8, and 9 is going to fall between 172 and 172, which is 172. Okay, so now that you find that, we've divided it into quarters. Now you can figure out what the interquartile range is. How do you actually calculate the interquartile range? Yeah, you actually subtract those numbers, which if you subtract that, it's going to be 26. Okay, now, the question is, what does that mean? What do any of those numbers mean? They're just random numbers. That's why somebody said, hey, dude, we got to have a way to graph this. And so they invented the box and whisker plot, otherwise known as the cat plot.
Or walrus plot.
Or the walrus plot, okay. All right. Okay, the numbers you just found are the box. Okay. You'll notice I made, over here on the right side, I've made a rough scale. Your scale can go up and down, or your scale can go sideways. I don't care. Just make yourself a rough little scale. These don't have to be super fancy. Okay, you need to plot those three numbers we just figured out, the median and the two quartiles. Okay. So median was 162. So I only want you to just kind of guesstimate, okay, 162 is a little bit above this 160 line. Nice if you'd label it for me. That's one part of our box. Our quartiles were at 146. So guesstimate about where 146 is. And 172. Okay, now, why did I draw lines there? Those are the sides of the box. Now just connect it. You just made the box from the box whisker plot.
How'd you find the quartiles?
There are 16 numbers up here. If that was on the 17th, there were 16 numbers above. I had to go find the middle of 16 numbers, which meant I counted to the 8th and the 9th on both the top half and the bottom half.
So you're finding the median, yes.
I'm finding the median of the median, yeah. I'm doing median of median. Yeah. Okay, that's the box. The interquartile range, remember we just subtracted 172 to 146? The interquartile range then is telling you how long the box is. The box is 26 units long. Okay. That's what percent of your data? If you just divided this into 4 equal parts, that's in that eighth, a quarter, and a quarter. So that's a total of 50%. That's the middle 50% of your data. So yeah, it tells the interquartile range is telling you how spread out the middle 50% is. So her bowling scores only vary by 26 pins in the middle half of her scores. If you're a bowler, 26 pins isn't very much. So, you know, she's pretty consistent. That's saying her middle scores are pretty consistent. She doesn't have a lot of variation there. Okay, now, here's where I'm not sure if all of you have learned this based on which school you came from. You can just finish a box and whisker by drawing whiskers on it. Do you remember where you drew whiskers? You drew, yeah, you drew it to the highest and lowest number. So we go to 125 here, and we would draw a whisker. And then we would draw a whisker to 219. Isn't that an awfully long whisker? Okay, and that's where somebody said, whoa. There comes a point, I mean, that's showing you your quartiles. Each whisker is a quarter, that's 25%, 25%, 25%, 25%. So that tells you your top 25% of her scores, they're really spread out. But somebody said, okay, that's almost too spread out. They said, if some numbers are so far out, we're going to call them outliers, and we're going to separate them from the whisker. Okay, so here comes the big part. This is the part I can't get people to remember. How do you figure out an outlier? Whether is 219 an outlier or not? It looks like it's really far out there. Okay, it's an outlier if it's more than 1.5 boxes away from the edge of the box. Okay, well, let's translate that into math. It makes more sense. Okay, how long was the box? That was called the what? The interquartile range. So that's 26. So what you need to do is actually let me write this in steps for you. You need to take the interquartile range times 1.5, because you need to find out how far is 1.5 boxes. So in our case, 26 times 1.5 would be 39. Okay, if we have any data that's more than 39 points away from the edge of the box, it's an outlier. So you have to find where are the boundaries. We'll do the upper boundary first. It tends to make more sense. Okay, where's the boundary for an outlier? I said if it's more than, in this case, more than 39 away from the edge of the box. What's the top edge of the box? 172. So in our case, the top edge of our box is 172 plus the 39 we just calculated. That's 202. That's 211. Okay, that's the boundary. If you have any numbers above 211, they're outliers. 211 is not an outlier. 211 is just the boundary where outliers start. Okay, so to get this in symbols, though, what did you just do? Call this number we just calculated a number, 39 some number. You just took the upper quartile and you added that number on. Okay, so did we have data that's above 211? Okay, you have to look at your actual data. How many numbers did we have above 211? Just the 219. So 219 is an outlier. We don't draw the whisker to 219 anymore. It's just out here as a point all by itself. Okay, Mr. Rhythmic. Where do I draw the whisker to then if I can't draw it to 219? You have to go to the next actual number in the data, not to the 211. 211 wasn't actually part of the data. The next number in your list of data is 192. So you're going to draw it to 192 now, which is way shorter. So now you can see, oh, most of my data was right here in this whisker. I just had one wild number out there. Makes it much more understandable to see how spread out your data is. Okay, is 125 going to be an outlier? No. Doesn't look like it, but you're going to prove it to me. Okay, so how are you going to find the lower boundary? Yeah. You're going to take the lower quartile and do what? You're going to subtract that number you calculated. So in our case, the lower quartile was 146, and if I subtract the 39, that's 107. We didn't have any data below 107, so we don't have any outliers on the low end. Yeah? Colby? Yes. Look alive.
Wake up.
Okay. This is not hard if you practice. I cannot get people to get this down. Not hard to do box and whisker plots and outliers. Okay. I think I'm going to let it run.
We're done, right?
Well, hold on. I need to show you.